So welcome back. We're gonna propose a solution for the twin primes theorem with the prime tens theorem that there is an infinite number of tens with four primes. My name is Manuel P. Rodrigo Velasco and this is my proposed solution. I know most mathematicians will say that the prime tens don't gonna be an infinite number of those, but I'm gonna show why they will coming back. First is the creation of prime terms. If you see, the cycle of 3 combines with the cycle of 7 and creates a cycle with 3 prime terms. Each prime term combines with the other prime terms, right? So then comes the cycle of 11, and the cycle of 11 will combine again with the cycle of 3 and 7 that has 3 prime terms, and the cycle of 11 has 7. So there will be 21 prime tens, and that will combine with the cycle of 11 and the cycle of 13 and the cycle of 17. So in the cycle of 13 they will have 189 prime tens, and the cycle of 17 you will have 2457 prime tens that they will be inside the perfect cycle. They will not be in the real number line, but will be inside the perfect cycles. All these combinations indicates that all those prime tens that inside of the perfect cycle, they will come back at some moment. They will come back, they will become real at some point, trillions of numbers away, but they don't disappear, they don't get destroyed. Okay, so you see also that the length in cycle by tens gets bigger and bigger also, and the proportion of prime tens gets smaller. At the beginning of each iteration of a cycle, this is the first iteration, second iteration, third iteration, the perfect cycles will be like having a symmetry on the middle with a prime ten on the middle, and in both sides, in the second 10 of both the end and the beginning of each cycle, we have a prime 10 also. All of the other prime 10s will be symmetrical distributed in the cycle. So this is the gap. Every perfect cycle will have a gap that its composition will be added to the real number line. Okay, so in this cycle, the first one, this is going to be the gap that belongs to this cycle, and then next cycle, this is going to be added, and the other cycle, this is going to be added. So we will add to the real number line as we are making more cycles and we know more the composition of the next cycle. Okay, that's what is happening. Okay, so the gap length, that's the formula, and I calculated two gap lengths. You see that this is a smaller cycle, has a gap bigger than the cycle of 29. What increases and decreases the prime times? Increases a diminish in prime flips. It's affected by the decrease of proportion of primes. When you have less primes, there are going to be less prime flips, right? So a decreasing change of the perfect cycle to the next copy of the perfect cycle. So that's important. When you have one perfect cycle, for example, the cycle of perfect cycle of 19, and comes the perfect cycle of 23, if gets a better copy one of each other, that's gonna help the prime tens to come out. I will explain that later because this is the key to all this study. One of the keys, a gap increase, we saw that already, and what is decreasing? a combination of non-prime tens with other tens, increasing the distance between prime tens. Okay, so if you have tens that are not prime tens, they're gonna combine with all other tens, and they're gonna produce an amount of tens that are not prime tens that gonna get in the middle and gonna start the prime tens getting apart from each other. Okay, they're gonna destroy them. Flip of potential primes, an increasing proportion of length uh, of the new cycle to the gap, right? Uh, and a gap decrease also benefits the decrease the prime tens. So what we can see is that the new cycles can flip all tens in a continuous process. It's a process of creating, making a space for all combinations. And remember that you are putting all possible combinations of cycles of primes once and again in a symmetric way. So this combined with this and then gonna combine with this. There is the prime tens combinations don't gonna go away ever. You're gonna have them inside the prime cycles and they will come back later, the prime tens. So this is the most important tendency to stabilize and repeat primes. Approaching zero change. What that means? Imagine you have an ideally prime 10 prime. So all are prime 10s in that prime number. That's never gonna happen. But if you have all prime 10s and you combine it with another cycle, you're gonna repeat this next cycle the amount of times of the 10s you have there. So if you have 7, you're gonna have 7 copies of this. Exact copies. And that's what I mean with duplicate. Any cycle merged with an ideally all full 10 cycle will duplicate exact copies of the cycle. This new variable is the duplicate proportion. So you know that there is only 4 no prime 10s in each prime cycle, individual prime cycle. So you have only 4 always. I will show you that in a moment. So for example, in the cycle of 7, you will have 7 minus 4 divided by 7, and that's the duplicate variable, right? And 11 gets to 0.636, 23 to 0.739, 101 is already 0.96, and such big number like that, in the millions already, it's 0.9999. So in huge numbers, you are approaching 1, right? And the duplicate of 1 will be exact. So you can see as the prime goes up, is bigger, more prime tens you're gonna have in that cycle of that prime. So it starts with only 1 prime 10, and then you have more prime times, until 17 that you have more prime tens. So this is approaching perfect prime 10, right? Of all tens. The prime tens combined grows exponentially, and this is okay, the length of the prime cycle of each prime cycle. So for 11 is 110. The length of the cycle of the perfect cycle combined 3, 7, and 11 is 2310, and this is the number that this cycle of 110 gonna cycle around the 2310 21 times. You see how increase fast. So the cycle of 130 will cycle to 231 times through the big cycle of the perfect cycle from 3 to 13. Okay, so the length of the cycle. The length of the cycle is the length of the previous cycle times the new prime number that is combined to make the new cycle. Okay? And we are defining the variable s of a cycle from 3 to p.m. as the number of prime tens that has. And that I am including the prime tens that are in the real number line, because the proportion is much more bigger in the perfect cycles. Inside the perfect cycles is much more bigger, the proportion of prime tens. So for a new cycle, the new number of prime tens will be the last number of prime tens in the last cycle times the prime number, okay? Minus 4. Our prime numbers has minus 4 tens that are not prime tens. For example, if you have the prime number 13, so you will have this formula, okay, from 3 to 13. So you will have the number of prime tens in the cycle of 3 to 11, that's 21, multiplied by 13 minus 4. 13 minus 4 is 189 prime tens. So this is the formula for the prime tens, right? And this is for the formula for the length. And we're gonna play a little bit with the formula. If we approach big numbers of prime n, then we can say, just to make a proportion, that the number of prime tens will be equal to this, to the number of the previous prime tens, then 2 times the new prime number, right? We are taking away the 4 because it's going to be very, very small. So if we make the proportion of prime tens to the length of the cycle when they are approaching infinity, you're going to have this, so they're going to be multiplied by the same number, prime n, right? Because they're going to be multiplied by the same number, they're going to be a constant. So you see, we will have a constant slope. And if we have a constant slope, at that point, the prime tens don't gonna be separated anymore. And the prime tens, you're gonna have so many prime tens as the length increase in the same proportion. As you approach this, the prime tens are gonna start coming out, but they're gonna start coming out with a so huge separation of trillions of numbers. But you will always have prime tens. You will always have prime twins. The composition will get steady. So these cycles that they are barely equal one from each other, they produce a real part in the number line, okay? And the gap of each perfect cycle will reflect the same proportion of prime tens as in the cycle, okay? Will reflect that to the number line. Prime tens will be at the same distance in the real number line as in the perfect cycles. The real numbers will have the same composition of the perfect cycle because the gap is gonna be building that, right? When prime x gets big enough, of course, there will be an infinite number of tens full of primes. And that's very logical. So we approach a slope constant, but really the prime tens have been separated so far away from each other. Okay, so what is happening in the cycles? the cycles, the perfect cycle will not be a reflect of the real number line, or the real number line will be a reflect of the perfect cycles. If you have, for example, so a prime number of m minus 1, this big, is so this big. The other one gonna be a similar wave, very similar wave, because Pn is so big already. So you're gonna have this times Pn on top, but it's the same wave almost that in top, but it's repeated more times. So these are the equations, and these two equations with the study of the perfect cycles and their characteristics and how they produce parts of they go producing parts of the real number line with the gaps is my proposal for the solution of the twin prime theorem. Okay, there will be a infinite amount of prime tens, prime twins, everything of them. So we approach zero chains as we approach infinity for an approach to a constant proportion of primes, or no primes, or twins, or unprime tens. All of them will have a constant proportion. Approaching constant slope as numbers approach infinity. Distance between primes, twins, and prime tens never decrease but get stabilized. Tens are always the same size, gaps are increasing until they get stabilized also, right? Remember that we are working with numbers that computers cannot reach. That's why they didn't see this, because they can't reach so far away until the slope gets stabilized. It's so many trillions and trillions of numbers. It's too far away. Tens combined with all possible combinations in a symmetry process. There is a process of creating. Nothing is destroyed. They are just putting apart the prime tens. They are not getting put it away, okay? There will be always tens full of prime. And you have to check between Riemann zeta zeros and perfect cycles and all those equations relating. Check symmetry cycles with the 1/2 Riemann zeta function line and other lines and contexts. We have to make more equations about the perfect cycles to compare them and try to find some connection with the zeta functions. And very important, check the symmetry lines, right, with the imaginary plane. And these are prime numbers, two prime tens, two tens full of primes here. Look, this is in the millions already. But this is a small number, really, really small. They're gonna get separated apart so much more. Prime numbers are a symmetric wave to infinity. And we will see very far away that in the real line of numbers. Thank you for watching. My name is Manuel P. Rodriguez Velasco. This is a proposal for a solution. I know this is the way science works. We will see if you find some mistakes, if you find some better explanations, everything. I'm open to everything. Thank you for watching. Bye-bye.